Mr. Eric, Mr. Ryan, right?
I guess.
Okay, you guess. Okay, so let's look at these numbers. Let's say we have like a parking space, okay? 100 parking space. From 1, 2, 3, 4 to 100.
That is not 100.
Roughly. Obviously, I don't have enough space
Because
to
10, because then 10 will be like half. It's not to scale.
Very good. Okay, thank you. Okay, let's say if we have like a few reservation from 2, both are integer. So for example, if the value is 2, 3, it means that this is reserved. And then 5, 6, maybe here 5, 6, this is reserved.
Reserved for what?
Parking space is reserved.
That doesn't really make sense because it'll be hard to park and it'll be packed very tight.
Okay. We don't worry about other conditions at the moment. Okay, so let's just look at this. For
Yeah,
example,
but
like
you think of like reality.
okay, so 7, 9, right? Obviously, right? Okay, and
Is
then
that a bus?
yeah, could be 8, 10. Okay, so 8, 10. Now we have a overlap. So we just do this.
Exactly.
Okay, we have overlap. So maybe parking is not a very good example, but
Yeah, parking is not a good example.
okay. So let's forget about parking. Forget about parking because that's going to confuse you even more. Let's just say we're given like a line with this integer point like a ruler, right?
Let's say a bed.
Okay, a bed. And then we're given this coordinate. We're given the intervals, right? We talk about many interval problems, intervals. Coordinates. And the question is that after this, we want to count how many points are taken. For example, here, this point is taken. So 1, 2, 3, 4, 5, 6, 7, 8. Numbers between from to 2, inclusive, are taken. Obviously, some points may be overlapped by multiple intervals, and we count it as once because this point is taken. It can't be taken more than once. Okay, so this is an interval question, and we talk about how to count how many intervals. It's quite similar, except that we are not counting how many intervals, we're counting how many points in a discrete line from 1 to 100. There are quite a few solutions. Given this number scale, 100, how do we check? We're given this 100.
What's the problem?
The problem is that we're given a few intervals from 2, right? 2 to 3, 5 to 6, 7 to 9, 8 to 10. If we plot the line of the interval over this line, and then there are 100 points, and we want to count how many points are taken. For example, in this case, 2 to 3, 2 points, 5 to 6, 2 points, 7 to 9, 3 points, 8 to 10, 3 points, but A is counted only once, right? So how many points? 1, 2, 3, 4, 5, 6, 7, 8. 8 points. So the question is that how many points are taken? The points are integers.
Do you do this enumerate thing so that count how much? No, not the index. I mean like that thingy-majiggy. Index and values, I think.
Index and value, yeah. That's a function. So, but how do we apply that to this case? Let's consider that 100 buckets or 100 something, 100 box. And then let's say 100 bucket, right? So 100 buckets like that, right? 100 bucket. And each bucket has a number like 4 or 5, right? So the proof of
the bottoms need to be round, not flat. No, not that, because that's a glass one that you can see through it. You need to do.
bucket.
No, I'll show you like this.
Okay.
Okay, it's like this. Like this.
Yeah.
And then you can do this. And then.
Okay. I see. It's like that. Okay. Okay, so we're given this 100 buckets, right? 100 buckets, and from 2, given this interval, we can just iterate over each bucket within this range to put some water in there. And then after this, the second step is to go through from the first bucket to 100 bucket to check which bucket has water and count it. Will that work?
Yes.
The problem with this approach is that if this upper bound, if it's 100, that's fine, we can brute force quickly. But if this is like a million, then that's going to be a problem because we're going to iterate over a million buckets to count it. And then we talk about intervals, right? The one solution for almost every interval problem is to sort it. Why we need to sort it? Because we want to look at the intervals from left to right. So we kind of need to sort the intervals. Okay, so let's write the brute force one. Define f given the intervals, right? Array answer at the beginning 0. So the bucket, right? Bucket at the beginning 100. Let's say 100. 0 times 100 over 1. From 1. Start from 1 to 100. So now we just go through from for ij in A, then for k in range. So this is the interval. We want to iterate over each bucket inside the interval, which is I to j plus 1. And then we set the bucket bk equals 1. And then at the end, we just need to count. We need to count how many ones in this b bucket, right? So we can do this sum b, and that's it. So obviously, this sum function, we can go through from 1 to 100 and edit the value, accumulate the value, but we have this mass function to sum all the values in the array. So the time complexity for this one is just O n, if n is the number of the intervals, right? Because we need to go through this. This one is O n, right? But this one, as we said, the range of the interval is within 100, so this must be a constant. So if it's a constant, we just ignore it, we just don't count it in the complexity. The time complexity is O n. The space complexity is O1 because this is the fixed size buckets, it's 100 buckets. Okay, so one problem of this is this one. This is not very effective. This is not very effective. You're given, for example, 1 to 100, this interval. You iterate over this interval to set each bucket to 1. So the loop will go like this, 1, 2, 3, 4, counting up to 100, right? Counting up to 100. So this is like brute force. This is the simulation. This is not very effective. One way of doing this is that we can do this. Look, this is a trick. This is a trick, okay? So look at this line, right? This line. Instead of counting, this is 1, 2, 3, 4, 5. Okay, so we can do a line sweeping. Look, we have like 2 to 4, and then 3 to 5. Okay? So 2 to 4, 3 to 5. These two. So for this one, you just like, okay, we have 2 to 4 interval. Then we set the bucket 2, set the bucket 3, set the bucket 4. We have an interval 3 to 5. We set the bucket 3, we set the bucket 4, set the bucket 5, right? Okay, but we can do this. We can use a hash map. So 2 to 4. Okay, so let's say we have a starting interval 2. We plus 1 here. Counter plus 1 here. And 4, it ends up at 4. The fifth one, I should minus 1 here. So here, I should minus 1. So 3.
Subtract 1, by the way.
Yes, subtract 1. Okay, so 3, look here. The interval starts with here, so I plus 1 here. And then it ends at 5th. So at 0.6, right? At number 6, it should subtract 1. Okay, so why is this useful? So basically, from 2, we add 1 at the from and subtract 1 at the next point, ended after the end point. If we just mark this, right? If it goes from left to right, 1, okay? If it's 1, then we accumulate answer. We know there's 1 point taken. We have balance. Balance equals 1, right? Balance equals 1. Now, balance equals 2. It's positive. We still add 1 because the balance is positive. It means that we have a point here, right? Okay, here. Nothing because this is 0, right? Here, subtract 1, the balance will become 1. And obviously the balance is still above 0, then we plus 1 here. And then here, subtract 1, the balance is 0. So we just count how many points that the balance is above 0. So look, 1, 2, 3, 4. Okay, so there are 4 points which are above 0, the balance. So is that the answer? 2, 3, 4, 5. Right? 2, 3, 4, 5 is 4 points. Am I right? So why this is useful? It means that we don't need to go into the intervals to set them accordingly because there might be overlapping, right? For example, like if every interval is 1 to 100, then every interval setting the 100 buckets continuously every time. There's no need. If a bucket has been set, then that's it, right? This way, for this method, we just mark it the start as +1, and then after the interval, we just subtract 1, marking it that this is the end of the current bucket, and then we go through from left to the right to accumulate those +1 and subtract 1. And if the balance is above 0, it means that there's a bucket here, right? If the balance is 0, that means that there's no bucket. If the balance is 0, then we just skip. If the balance is above 0, then it means that the point is being taken by at least 1 bucket. Okay, and then we accumulate. We talk about many interval problem, and this is line sweep. And previously, we can use the line sweep to count how many intervals. Right? How many intervals? Remember we talked about it, how many intervals. And this is similar. So this is 2 approaches. Another approach is that we sort the interval, right? As we said, we sort the interval. For example, like 1, 3, 2, 5, and then 8, 10. Okay, so for example, this, we sort the interval. And then you need to tell me sorting by the first coordinate, by the start or by the end. 1, 2, 3, 4, 5, and then here is 8, 10, right? 8, 9, 10. So the answer is 1, 3, so it's this one, this one, this one. 2, 5 is this one. 8 to 10. So the answer should be 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the answer. Okay, so we sort the coordinates, sort the intervals by the starting point, which is 1, 2, 8. Okay, we can sort it. So a dot sort by default is sorting the first coordinate. If you want to specify clearly, you can say key. We want to sort by the key equals lambda x0. So it means that x we want to sort it by the first value, which is the first coordinate. Okay, so sorting is O(n) log n, right? If there are n intervals, the sorting takes O(n) log n time. After sorting, we go through this. For example, we go through from the left to the right? At the beginning, the previous is -infinity. This is previous, right? Every time we update the previous to the endpoint. So why this is useful? For example, the previous point is here. The previous endpoint is here, right? I'm considering the current interval. There could be a few situations. One situation is that it could be here, right? Like that. Or the other situation, it could be like that. Or the other situation, it could be like that, right? If the situation is this one, this is for example, this is AB, the new interval is AB. If A is bigger than the previous one, then we just need to accumulate this bit, right? Accumulate this bit. There's an overlapping, then we have to just add this. And then if it's smaller, then we don't need to accumulate because this is already accumulated. Okay, we worry about that. Okay, can we just focus on this, okay? Okay. We sort the intervals, then we go from left to the right. And then we keep tracking of the previous, which is the maximum, the last endpoint of the previous interval. We need to use the previous endpoint. So current endpoint, which is AB, right? From 2, AB, this is A, this is B. Then we check if A is bigger than previous. It means that we have 2 non-overlapping intervals. So if we have non-overlapping, then we can just accumulate the points taken in this interval, right? And if the previous is here, and then if current has an overlapping, this is the previous one, right? Previous here. If current has overlapping, then we have to accumulate this bit, right? Accumulate this bit, am I right? And another situation is that if this is the previous one, and then if we are here, right? We are here, then we don't need to accumulate because this bit has been calculated, has been accumulated in the previous one, right? Does it make sense? Do you understand this? 1, 2, 3. Yeah, there are only 3. So for those interval questions, right, we can just sort the intervals from the smallest to the biggest by the from. Okay, and then we go through from the left to the right. It's kind of like line sweeping as the second method. Okay, so let's write the code. Okay, and that's it. Define f a answer equals 0, previous equals -infinity. Array dot sort. This is sorting by the first coordinate, or we can say sort equals lambda x0. Then we go through this array. Let's make it array. array, okay, for A, B in array, right? Then if this A is bigger than previous, okay, if it's bigger than previous, then we need to accumulate this answer, okay, answer equals 0. Answer plus equals B minus A plus 1. This is previous, this is the current interval A, B, right? If this is bigger than previous one, P equals infinity, then we just need to accumulate this bit. As A should be here, right? A should be here. Or B. A could not be here because we are sorting by the first coordinate, so A must be here. So A is here, then we need to accumulate this bit. But B could be less than P, right? So we just have to add answer plus equals the maximum of 0 and this bit, right? B minus P. Okay, no plus 1, right? Because P has been taken, so we know plus 1 here. And then each iteration, P equals the maximum of P and B. We are storing the larger value of the B, so which is the rightmost boundary, and then return answer. The time complexity for this one is sorting, right? Sorting, this is O n log n. This one is O n. And so the overall time complexity is dominated by the sorting. The time complexity O n log n is slower. But previous to approach, why is it fast? Because we make an assumption that there are only 100 packets. 100, the maximum coordinate is 100. But this one, it doesn't matter, right? The coordinate could be, there's no upper bound. Okay, so one more thing. Why this is plus 1 here and this is not plus 1? I was just explaining. There is no plus 1 here. Because the first time, we want to accumulate 2 to 3. How many points? 3 minus 2 plus 1. Okay? If we want to accumulate, if we look, this is 2 to 3. And if I'm saying this is 4 here. And how many points I should accumulate? I should accumulate this 4 only. I should not accumulate this 3 because 3 is already taken already. So we don't count it twice. So it's B minus A and that's it. Okay, that's the difference. That's why there is no plus 1 here. So another question is that if we sort by the endpoint, then that's going to be a problem. If we send the endpoint, then this A to be here, right? So you will miscount this bit. You will miscount this bit. Okay. So that's why we need to sort by the first point, which is the start point. Okay. Okay. That's it for today. Bye bye.
Yay.
Bye bye.
Beer.
Bye bye.
Beer.